Okay, today we're going to talk about angles of elevation, and I want you to set up your foldable so that you've cut out the section and you have it folded. So on the outside you have your angles of elevation and angle of depression, because this crease line or the cut line edges of it is basically our what's called our line of horizon. Okay, because think about it, if you're standing here, you're standing on the line of horizon, and when you're doing an angle of elevation, it's basically because you're looking up at something, and so that becomes your theta. Whereas if you are standing here, this becomes your line of horizon, and because you're looking down into something. Okay, so the angle of elevation is always of your line sight upwards, and it's always inside the triangle that's formed, because basically since you're standing on the horizon you have a right triangle here. Okay, and you're looking up. So let's think about this and how we can use this. Let's say I'm out flying a kite, and here's my kite, and I'm standing here. Okay, and needs a little tail, and I have the kite on a string, and it is 150 feet long. Okay, and I want to know how high is my kite up in the air. So here's my line of horizon, and if I drop that altitude down from my kite, it makes a right triangle. Okay, now I know that I'm standing there and that I position my arm so that I have my triangle is at a 45-degree angle so that I can measure this out easily. And so therefore I can use the trig ratio to find the height of the kite from the ground. So since I know my opposite over my hypotenuse, I can use my sine of 45 equaling x over 150. Now, you have two ways you can solve it. The first way is I can just cross multiply and do 150 sine of 45 is equal to x. Or you can take what you know about the sine of 45, which is that is equal to the square root of 2 over 2, which is equal to x over 150. And when you cross multiply, and you get 150 square root of 2 divided by 2 is equal to, well, it's not going to be divided by 2 until I've got the 2x, because then I'm going to divide by 2. And either way, both of these answers here are going to give me that x is equal to, let's see, we'll do 150 sine of 45. And then I get that my kite is 127.6 feet, approximately, feet up in the air. Okay? Now, angles of depression are for when something's looking down, and your angle of depression is basically outside of your right triangle. And if you think about it, if we drop the line here, we have a right triangle here, and we also basically have a right triangle here. And our theta this time is kind of outside of the triangle that you've created. Okay? So you can use the angle of depression a couple different ways. But let's say that I am an airplane. Okay? And my control tower is here, okay, and I know that right now the plane is at an altitude of 12,000 feet. Okay, and my line of horizon is going to be here, and I know that in the distance or the angle of depression is at a 32-degree angle. Okay, now you can go about solving the angle of depressions two ways. Number one, because you want it inside of your right triangle, you can either find your complement here, which is going to be 58 degrees, Or you can think about the fact that, because I want to know how far away we are from the tower, sorry. Or you can think about the fact that basically this is a transversal between two parallel lines, which gives me an alternate interior angle. So this angle over here has to be 32 degrees. And then that means that I can kind of say, oh, all right, well, my line of sight is now inside, and so I'm kind of having an angle of depression, and I can set up the same ratio as I did for the angle of elevation. So for this particular one, now if I'm using my angle here, I have, I know the opposite, and I'm looking for my adjacent. So I can say that the tangent of 32 is equal to 12,000 divided by x. And so when I cross multiply, I'm going to get that x tan of 32 equals 12,000. And then I divide both sides by the tangent of 32 and plug and chug in the calculator, and I get that the plane is now 18,154 feet away from the tower.